trying to see how sensors and sensor networks are used optimally to acquire really good quality data for science, where appropriate, not always. I mean, there's a big believer in keeping people closely involved in measurement and observation, particularly in research institutions. That's really important. But there are places certainly where sensors and sensor networks have a really good role to play in science. Whether it's things like improving measurement precision, increasing the temporal frequency of sampling or the temporal extent of sampling, or as in some of our cases, some big multidisciplinary projects, some of the biggest problems we had was just user bias, and you've got big collaborations and you've got training students, and at the end of the day, some of the errors that were introduced through that subjectivity really overwhelmed our ability to be able to draw inferences. So that's the sort of thing that's motivated this business. So sensors and sensor networks have got their own set of challenges. So we, I should just say, we work with a lot of, primarily with the research sector. We do work with the private sector, but mostly with research institutions and universities. But we do everything from sensor design, manufacture, installation, maintenance, data management, and visualization. And I think it's questionable to how sustainable that is over the longer term, but certainly for the last 3 to 4 years, that's been really valuable in terms of giving us that continual model of learning and improvement of the sensor. So when we design a sensor, install it, after a couple of years, we can see how that can be improved to improve the reliability. And also when we're looking at data and writing the code for visualization analysis, we understand how the sensor design has directly impacted the quality of the data we're getting at the end, and then feed that back into that development. I'm not really going to go through all of these, but this is just some examples of some of the projects, some of the things that we do, and some of the technologies we work with. The business is still pretty small, and I work with my brother Amory in the business. We've decided to keep the growth reasonably modest, and we sort of draw on our professional network as needed. He's the data guy, so he's got 20 years of experience in the IT industry, designing and developing databases, and he's got a pretty wide network of data professionals that we draw on as needed. So traditionally, we sort of work predominantly with things like databases like Oracle or MySQL or Microsoft SQL Server on sort of institutional infrastructure, but progressively more cloud-based computing and data storage solutions. Just responding to some of the questions that were raised and we're responding to. One of the biggest challenges for us in this business is the pace of technological development in sensors. There are so many new things being released all the time, and it's a very exciting time. But at the same time, that raises a few problems. One of those is maintaining control over long-term availability, consistency of hardware, and we've been, particularly with long-term science projects, we've been caught out where suddenly hardware vendors will discontinue the provision of certain technologies, and you want to maintain consistency in your measurement throughout experiments. And that's been a bit of an issue, and that's one of the reasons we undertake a lot of our own design and development of hardware, just to maintain that control and certainty of availability. The other thing is there's various projections, but there's a lot of estimates out there about the cost of sensing, and generally, as a general rule, the cost of sensors is decreasing, largely due to things like the Internet of Things and automation of manufacturing and logistics and transport. So there's a lot to be gained from that, but we really need to understand the trade-offs in sensing cost, precision, and reliability, and that's in a way it's almost a case-by-case basis. In some situations, there's good cause to go to lower cost technologies, but what are the implications when it comes to peer review publications and things like that? Does that still meet the expectations of the science community? And also how do we, for example, pair lower cost sensors with benchmark technology? So we've got an increased data volume, but we've got data that still has a measurable confidence. And ultimately, we need scientist feedback to really understand how best to do that, as projects are being undertaken. In terms of how science can help environmental sensing systems, well, we really need guidance on important new scientific findings. We can't stay up to date with all the literature and all the conference proceedings, and there's been a number of examples of where I've benefited a lot from discussions with scientists like Tim Brown on the phenomenological imaging, or Albert Van Dyke on on things like stem compression and rainfall inception. I mean, they've led to the development of new sensors. That's been great. And I'm interested to hear what sort of opportunities there might be to engage with scientists and students, particularly students, to test some of the new sensors that we developed. And we did that last year with an A&U honours student. She took some of the sensors we developed and undertook a research project to validate them extensively in the field. That was really valuable for us. But that was really, in some ways, just a lucky alignment of events that how that came about. So I'm sort of keen to see how we might do that in a more structured way, because it really is a time-consuming process, not just to get a new technology working, but to say it'll still work in 6 months, in 12 months in a field environment. In terms of working together, we can do simple technology delivery projects, and we have done that, but our preference is certainly for more of a long-term research style of collaboration and project delivery. And part of that, an important part of that is it's exciting for me to still be working in science. I still think of myself as a scientist, but probably more comfortable in that space between industry and science. I think it's probably I guess what am I trying to say? It's about the joint acceptance of the risks and uncertainties, and it's a two-way street. So we understand that when a scientist comes up with a new idea, you're working at the cutting edge, and you say, I want to develop a new proposal that measures these attributes in this way. Can you help us to do that? I think the scientists understand that sometimes it takes a few iterations to get that measurement technology exactly right. And the scientists I've worked with today have been fantastic. And similarly, we understand that not all it's not necessarily easy to define with great detail right at the start of a new idea the specifications of the technology you need. So we need to be a bit flexible as well as a scientist sort of gets a bit more clarity about their ideas. And so I think that's why I still like working with scientists, because I think there is that sort of shared understanding of some of the risks and working at that level. So it's a really exciting time to be working with technology and science implementation. And I think for us to make the most of the opportunities of the technologies and avoid the pitfalls, I'm really keen to work more with the scientists and hopefully maybe this precinct might has got opportunities to do that. That's great. So, thank you. Justin.
Thanks for a good talk. On that point of understanding the trade-offs in sensor cost, precision, and reliability, oftentimes the biology, especially the ecology in the field, is the largest source of error.
Yep.
So it's just how many can we deploy out there, even if they're noisy and half of them die. You know, like the spatial heterogeneity, the temporal heterogeneity is the largest factor.
Absolutely, and in a lot of forestry applications, that's exactly the case. The greatest variability is the spatial variability in forestry, lots and lots of samples, and in those cases, it's really clear. You can say even if we can halve the cost of sensors, we can put out twice as many. And if 30% of them are dead at the end of our trial, we're still finishing ahead, and that's okay. We just need that advice right at the start to say that's a perfectly justifiable way to go about it.
The only thing is that the labor, whoever you work with, is the biggest piece.
Yep,
maintaining and deploying.
Yeah, that's right. Yeah.
Especially when it's costly. So that's the truth.
Especially where a lot of the sensors, sometimes we install things a long way away, and that's where the students I think are great to come in, particularly where we're based in Melbourne, and a lot of that trial we did with ANU was that was here in Canberra, and that was great. So the student could go out and check on the sensors and do the local field data collection, and I don't drive up to him every time that something goes wrong. So that's
what's your, like, in terms of joint acceptance of risk and uncertainty, what's your business model? So if you want to interact with scientists, and so we come with a new sensor that we want here, what's the business model on that? How you, who owns the IP?
Right.
What's the arrangement, and who pays for the cost of development?
Yeah, look, I'm pretty relaxed about a lot of those things, maybe more relaxed than I should be. I spent, during my time as a research scientist, a lot of time on things like patents and commercialisation committees and trying to lock down IP, and really, and while we're doing that, the science just moved on, and everything else, we're still sitting around meetings trying to work out the best strategy. So my view personally is
that I was in a meeting about it.
I really did. So my view is the best way to protect the IP is just to continually innovate and just to sort of get things out there. I sort of share I'm happy to share a lot of the things that I come up with. It maybe it's not the best, most lucrative business model, but it's we benefit a lot from the open source community. So a lot of the technology, even though we custom design sensors, a lot of those still based on open source architectures and things like that. So I think there might be cases. For example, I'm talking to Sarah now about making, I guess, patentable technology more accessible in terms of field trials and things like that. So that particular part of the technology will be secured in terms of IP, but we can just build everything else around it in terms of how you deploy it, how you do the telemetry, how you do the visualization analysis. So that can be done. But generally, I think most of the examples so far have been where people, the scientists and our business have got goodwill and good relationships, and we just, I guess,
I'm just thinking more about other companies that might want to prevent you to operate by putting a patent or something.
Yeah.
And if you don't have any IP protection of some sort,
that can
shut you down.
Yeah. So I think most of the technologies that we work with are probably, so some good examples, there's some technology I'm working on with Albert Van Dyke here at ANU. Those technologies have been published, and so that's sort of, I guess, to some extent public domain. The scientists there are very happy. They're from Europe, they're scientists, they're very happy to sort of see that their technology commercialised to some extent, but there's nothing stopping anyone else from doing exactly the same thing. So we just have to try and do it, I guess, better and easier than anybody else. And so I haven't quite got to the point where we've hit the Eureka button and said, okay, there's no one else has got anything like this, and then we might maybe have to talk to a lawyer, but I don't think that's a likely outcome. It's more about just making the technology easier, more accessible, and making the measurements more useful from a scientific perspective, and that's interesting from us, useful for the scientists, and I think that's probably where the business is.
All right, great. Thank you very much.